Hi everybody, my name is Oleksandr Romanov, and first of all I want to ask a little tiny question, all of you. So how much people from all the audience have ever tested some kind of application through its API? Just raise a hand. Okay, cool. Is it was hard or not so hard? I think it was like average. It depends on what kind of API and what is the size of application. And what about you will have a task before the release to test not only one application through its API, but 200 of applications, and to test it every week. So the release cycle is every week. Will it be hard? And for the team of the testers, it will be hard. So in today's presentation, I'm going to share with you the tools and techniques that you can apply in order to tackle the challenges that will occur if you will work with microservices. So first of all, what we will cover today? We will start with moving from what is monolithic applications and what is the difference between the microservices. Then we will take a look on how we can adapt our testing efforts for the new challenges that microservices will bring us. And in the end of the presentation, we will also think what else we can do in order to make our testing efforts even more effective than just by using testing and automation and all that stuff. So let's start. Just a few words about me to get the context. I'm from Dnipro, Ukraine, and I'm working in automation for more than 7 years right now. During these years, I've worked for various companies and have automated a lot of systems, starting from banking applications and to content management systems. Right now, I'm working at Playtika as QA automation lead. The Playtika is gaming company, so we are making games in social casino genres, casual games, and a lot of other stuff. So, first of all, the monoliths. I'm pretty sure that almost all of you have faced with monolithic applications, and we will try to find out what it is, even when you don't know that you have tested a monolithic application. So what does it mean? In the very essence, the monolithic application, it's when you have the backend of your system with some kind of API, and its backend is the one single code base with all the components that are working together. So inside this monolithic application, there are a lot of code, of course, that is dedicated to business logic, a lot of code which works with databases and the database itself. And you may have or may not, you will have the UI for interacting with this backend. So this is like the way applications are built starting from the beginning of web era, and it's pretty useful for today also. And how we get used to test such kind of applications. The most widespread way of testing or think about the test is described by Mike Cohn in his book Succeeding in Agile in 2009. And this is it. It is a classical testing pyramid or testing triangle, if you want. So the main idea here is that you need to concentrate more on the covering the unit tests, the less on the service or API tests, and you should have the UI tests, end-to-end UI tests, but you should keep the number of these tests the smaller than possible. So the technology world evolves, so the evolution never stops. So the user of our applications, they always want more. They want the new software to be delivered faster. So we don't want to release our changes or the new versions in once a year or once a month. We want to release even faster. And it turns out that monolithic applications in many ways are not so suitable for delivering fast and to moving to continuous delivery, continuous deployment, and all of these fast delivery tracks. So let me just point a few things that blocks monolithic applications from delivering fast. First of all, if you want to deliver even a single line of code in monolithic application, you need to redeploy the whole system. So in one case, if you have, for example, two identical production systems, you can just turn off one system, upgrade it, and in the same way, the other copy of your production will work and nobody will be affected, in theory. But when you have only one production system and you need to redeploy it in order to get your change, you need to stop it, put your whole application or whole website into the maintenance mode, upgrade your application, and then turn it on. And it also affects your custom experience, of course. Next thing. The next thing is when you're dealing with monolithic application, you are more or less tied to chosen database. So if you, in the beginning of developing of this green project, you or your team or your architect have chosen, for example, to use this particular type of database, for example, SQL or NoSQL, and you have put a lot of effort in it. So after a huge amount of time, like 5 or 10 years, it's really requires a lot of effort to change the database because you put a lot of code on it. Next thing. As your application, the monolithic application gets bigger with a lot of code, you definitely will have complexity. And it is also hard for new developers that are joining your team or your company to get through all these components, all these things, and to understand how they change will affect the system. Because when you change something in one place, it can affect anything in your system. So this is not the all points against or monoliths, but it's a few. So why microservices? The first thing that we want to understand, what is microservices and why they are better in some way. They are better for today modern, fast modern delivery of software. First of all, the microservices in its essence, it's the way how we build the backend. For now, the microservices can be used also, the microservice architecture can be also used on the front end using some modern frameworks, but the majority of the applications that are somehow use microservices, they are talking about backend. So what it is, instead of one giant code base, one giant application with all the logic, we are dealing with small services that are, each of these services working on their particular thing. They're doing only part of the work, and each of these services communicates with others. The communication can be like making HTTP calls or using some message queues or any kind of communication. So the main idea here is that you will have a lot of services and they are communicating somehow. So why microservices? Isn't it better to just use monoliths and that's all? First of all, the microservices, when you are dealing with these services, there should be small. The rule of thumb actually to have each service, the code base of the service, in that big that it can be rewritten by 1 or 2 teams for one sprint, so for 2 weeks completely. So they are relatively small. Next thing, each microservice is independent. What it means? When you are developing new service, you are completely free of using any kind of dependencies or any kind of way of communicating. So if your particular service, for example, is working with getting some data from social networks, it is more better to use and to store the data in the GraphQL database type. If you want to use SQL, you can do it. If you want to use SQL database and NoSQL at the same time, for the same reason, you can do it. Your code base is small, and you are free to use different technologies at once. Next thing, the development of new services is fast. And it's also really good for developers that the developers are not so tied to their code. If the developer works on their part of code for 5 years, it is really painful to discard all the code and rewrite it again. But if you are working on the code like for 1 month or so, you can throw it and rewrite it again. The next thing. This is like the main part of using microservices. It's scalability. So if you have in your monolithic application some part that requires to be scaled in order to some performance reasons. So you need to have more parts and you need to split the traffic against this like component inside the monolith. Unfortunately, you can't do this so effectively as with microservices. So with microservices, you can just have, if the services requires some performance justification, you just can can split the traffic against, for example, the 10 instances of one service. And you are completely free to scale it, each microservice in that particular way. And the last point is language agnostic. So the main idea in this service is that you are concentrating not on how it's built itself, but you are concentrating and testing the way how the services are communicate with each other. So it also gives an independence and freedom to actually build each service on their different technology. So for example, if you want extremely performant part of your service, you can write a service in C++. Or you can do other services in Node.js or Go or Java, whatever. So it's up to the team and up to the developers. So it may seem that the microservices are so great and everything is fine, just do it and you will succeed. But that's not so good. What about the other side? The other side, that you will definitely have more connected parts. Instead of one code base, you will have a lot of tiny little services that needs to work together and needs to be synchronized. So it's really challenging. Next thing, if you will choose the way when you implement each service on its different technology stack, you will have more technologies that needs to be work together, and you need to support these technologies in the new versions, which is also can be hard. Next thing, you will definitely have more data that needs to be handled inside your application and needs to be reliably get to the target points. So you need to think about it also. All of the things, like more technologies, more connected parts and more data, leads to more complexity. But there are some tools and techniques that can somehow decrease this complexity and do the testing and the development of the systems more useful. The next thing, and this is all leads to more unpredictability in your system. So it starts to get hard to test such systems manually at all, because you have like hundreds of components that are working together, hundreds of services. Each of these services will be scaled to any number of instances. So in the end, what you will get, you can get like 500, 1,000 of services, and each of service can fail. Of course, it's software. So you can't predict where the failure will be on the real system. Or you can predict, but the prediction will not be so precise. So, how actually can be tested such that a lot of services that are communicating with each other? So it turns out that the classical pyramid that have been offered by Mike Cohn cannot be just applied, blindly applied in this case. We should somehow adapt it to our needs. So we can adapt it maybe in a way of trapethium. It's all about the levels and layers that we are using for testing and automating the services. So when I will describe all these layers, it means that I'm not distinguished like testing and automation. It's all connected parts. Because without, for example, the exploratory testing in the top, all your efforts that you have in automation can be useless. And also, if you skip the integration testing using contract test level, you will also face with a lot of problems, and you need to definitely solve it. So let's do a quick review on what strategies and tools you have on each levels. And all of my examples right now will be mostly from Java world, but you definitely can find something similar in your technology stack, of course. So let's start. The unit test, of course, it's the mandatory for developers, and they are working on it using their approaches. The only thing that you can do right here, it's review this unit test if you have the skills, and to find where the unit test can be done better. And of course, one of the tools here is the testing frameworks, which is dedicated to particular language stack. For Java is JUnit and TestNG. For C#, for example, the .NET technologies, it's more to XUnit type of framework like NUnit. The next thing, in unit test level, we are focusing on testing one particular method within the class. And we are focusing on testing what actually our code is doing in scope of business logic. The next thing that we are going to test is component testing. Component testing is testing your service, one service, with all their dependencies locally in isolation. So what we are focusing on right here is the service public API. What about the dependencies? Because each service can have a dependency like databases, like message queues, like any calls to external services. So the way how we can do it, it's using virtualization, using Docker. So for any data storage, we can put it into Docker container on your local machine and make your service to use this storage. As for the message queues, for example, the Kafka, you can do the same. You can put it into the Docker container and make a service use it. As for the external calls to any external services, your services or any third-party services, you can use some tool which allow you service virtualization. In Java world, it can be Wiremark. It's more or less useful. So what it does, you describe what you will call to other services and what this other service should respond you in the form, for example, in the JSON. And you describe all the communication with external services using these Wiremark stubs. So you have tested the business logic on unit tests, more or less. You have tested the service in isolation through its API. What's next? The next thing is to use the contract tests. The contract tests help you to do the integration part of your work. What it means? Imagine the situation that you are working with a service, the testing of one service or automating it. This can be like the service A, and you need to test the integration of this service with some service B. One thing that you can do in scope of integration testing is cover it on the unit level. So it will be like that. On the service A side, you will write all of the unit tests for service B, for integration with service B. So you have created this test. The whole test suite is green, so everything is okay. You have run it on your local machine and everything is okay. And turns out that when you deploy the newly created code for service A on some kind of environment, and you have deployed the service B on the environment, and you start to test your services on the environment in the real world, at the whole system, you get the integration error. What it means? You get the error that the service B have changed the way how it communicates with you or with other services. So you have found an error in integration. Is it a way how we can reveal such error without deployment to any kind of environment on your local machine? And it turns out that you can do it. Instead of writing the unit tests, and by writing this test, we are assuming that the service B will work like that. But this is only our assumption. It's not like it's on the real world. Without writing this unit test, we can write the contract tests. So we are starting with defining the contract between the service. The contract means the description on how the services are working together in this particular case. So in our case, we are describing in one contract what kind of request service A is doing to service B and what kind of response service B should respond in this particular case. And after you have defined the contract, you are defining the contract test on one side and the contract test on another side. How the contract look like? If you are using one of the tool from contract testing world, it is Spring Cloud contract. The contract will be like that. So the contract actually is written using the domain-specific language, and it's written in Groovy. But you don't need to know the Groovy language at all, almost, in order to create such contracts, because you have a set of predefined methods which you can operate with. So in this particular contract, you are describing what you are requesting, the requesting URL and the method of request, and what you are expecting from other service, what data and what status code you're expecting in response. So here in contract testing, the main point is that you are focusing not on the particular functionality. So if I will send this, the service will return this. This is not the case. In contract tests, we are focusing more on what kind of data types you will work with. So in this particular case, we are expecting that the body of the response will be the JSON, and the ID will be integer, and all other parameters will be the strings. So for each of these communication between these services, you're describing the contract and the contract test. What actually it will bring us? How it improves our way of testing? What we get in the end is a lot of contracts and a lot of business services. So how it's used in practice? When, for example, service B wants to change his API, and according to this scheme, the service B is used by 3 services, A1, or A2, and A3. So if, for example, service B makes this change that will break service A, service B, and service A1, A2, or A3, the developer of service B will be automatically notified during the test run that this particular change in the API will break these contracts. So what the developer of the service B can do, it can be multiple ways. One of the things that developer can do, it goes to each of the broken contract, update it according to their change, and after that, the contract tests also will be updated, and the service B will be green, and everything will be okay. And in that moment, when the service B developer will update each of the contract, the developers of other services will be also notified that there is a breaking change and you need to respond. So you need to respond in the way of updating your code, or to reverting the contract or blocking the service B of doing this change. And the main thing here is that all of these results, test results, if anything is broken in integration, it will be done fast and on your local developer machine. So it's only in some way slower than the unit test. So you will get it almost immediately. The last part that we want to learn is where we can use contract tests and what are available tools on the market. Tools or libraries. First of all, what we can test? We can test service-to-service communication. The communication can be using the HTTP REST or the messaging. And also we can test and cover the client-to-service communication, even when the client is written on the different technology stack than your own service. And the tools? There are most mature tools that are available, like libraries. If you are using the Spring framework or the Java world, you can use Spring Cloud Contract. If you are not using the Java at all, but you want to start with a contract test, you can use the Pack tool. Actually, all of these blue lines inside the presentation are clickable, and you can get all information about the tool. So, in Pact, you are not focusing on particular technology, you are focusing on actually the communication between the services. So it's more useful in non-Java world. So, the next thing, you have covered your services on the unit level, on the component level, and also on integration level using contract tests. What else? You should cover your system as a whole using API tests and UI tests, of course. It depends on application, but in most cases you should cover both API and the UI. And in this area there is tools and techniques that are more or less covered. You can use the libraries like Rest Assured or Karate framework for automating UI. Or if you don't want to spend a lot of time on learning the language, you can use the tools which can help you a lot. The tools can be the Postman, some kind of proxies, or the tool like SOAP UI, which allow you to do a lot more than just HTTP API testing. The same situation is for the end-to-end UI testing. You can use the libraries, the Selenium WebDriver as a standard, but you are not tied to only the WebDriver. And you can use the tools. It's not the full list of tools, of course, but there are like a huge evolution in these tools that are not require you to use any kind of coding. You're just concentrating on doing codeless testing. Next thing, of course, you can't do effective testing without exploratory. So in exploratory testing, the most interesting way of doing it is to using the heuristics and the list of testing ideas, what they can bring you. It's a new way of looking on your application, of course. The way can be what if it will deal like that, or anything else. So you have done all these types of testing. What can be next? You are deploying your new change, and you can get this production incidents on the production. So what you have done wrong? It turns out that the testing before the production is not enough, and for microservices it's completely not enough for doing testing effectively and ensuring that everything is okay with your application. What we can do is testing in production. The few points that you can do in production for microservices as well is monitoring. So in order to get all the information about how the events handled in your application, without monitoring, it will not be possible to get bugs investigated. Also, you can do the tracing. To trace all the events and find out in what particular service there is an error. Another thing that you can do is feature flagging. You can release your features, but not open it for user on the production, but open it for your developers or your testers, and test it before it will be open fully. Another thing is that you can open your feature gradually and analyzing on each step of opening, analyzing how well from performance point of view the application and your services are done. And with dynamic traffic analysis, you can also perform the analysis why the issue is happening, and in some point use this captured traffic in your pre-production testing. So, what are the conclusions? First of all, microservices will definitely bring more challenges to you. You should always think about that when you are changing the way of how your application is constructed. You should also change the way how you test and apply the testing and the tools. Also, for microservices, it's completely crucial to have the testing in production. But you always should think about how your testing in production will affect the users. That's of course. And in the end, in microservices, the most critical thing that you need to know and you need to apply, this you need to zoom in and zoom out while testing. What it means is that when you're performing your test, whether it's automated or manual, you should think how this particular change will affect the single service and the whole system. So if you want to get information or chat about microservices, you can contact me, of course. Here is my links. And if you have any questions, just ask me. And here is the QR code to the presentation. You can use it and get the slides right away. Thank you.